The Illinois Department of Commerce and Economic Opportunity, or DCEO, provides information on electrical safety and code compliance. They can be contacted at 217 785.6133. The Illinois Electrical Association, or IEA, is a trade organization representing electrical contractors and suppliers, which offers seminars and training on electrical topics and can be contacted at 847.439-656. The IEA Lightning Protection Seminar is a 2-day seminar covering lightning protection systems, including TVSS, and is held annually in April or May. For more information, contact the IEA. The NFPA 780 Lightning Protection System Inspector Certification is a 3-day course that provides training on inspecting and certifying lightning protection systems, offered by the National Fire Protection Association, or NFPA. For more information, visit the NFPA website. IEA STT 1100-2018 Recommended Practice for Powering and Grounding Electronic Equipment is an ANSI-approved standard that provides design recommendations for electrical systems, including TVSS. Underwriters Laboratories, or AL, is an independent testing organization that certifies TVSS devices. Cooper Power Systems is a manufacturer of TVSS systems and offers technical support and training. Firstly, consult with a qualified electrical engineer to assess your specific needs and recommend an appropriate TVSS system. Secondly, ensure the TVSS system is properly installed and maintained according to the manufacturer's instructions. Thirdly, consider adding additional surge protection devices to protect sensitive electronic equipment. Fourthly, train staff on the importance of lightning safety and the operation of the TVSS system. Transient voltage surge suppressors, or TVSS, are designed to protect electrical and electronic equipment from voltage spikes caused by lightning strikes, utility switching, and internal equipment operations. Choosing the right TVSS involves several considerations. Firstly, determine the voltage and current requirements of the equipment you need to protect. This information is typically found on the equipment's nameplate. Secondly, select a TVSS with a voltage protection rating, or volts per mode, that is appropriate for your equipment. A lower volts per mode value indicates better protection. Thirdly, consider the surge current capacity of the TVSS, measured in kiloamps. A higher kiloamps rating indicates the TVSS can withstand larger surges. Fourthly, choose a TVSS that is UL listed, ensuring it meets safety standards. Fifthly, decide between hardwired and plug-in TVSS devices based on your installation needs. Hardwired TVSS devices offer better protection for entire electrical panels. When installing a TVSS, follow the manufacturer's instructions carefully. Firstly, ensure the TVSS is properly grounded to provide a path for surge current. Secondly, install the TVSS as close as possible to the equipment it is protecting. Thirdly, use the correct wire gauge and connections to prevent overheating and voltage drop. Fourthly, regularly inspect the TVSS for damage and replace it if necessary. TVSS devices come in different classes, each suited for specific applications. Type 1 TVSS devices are installed at the service entrance, providing protection for the entire facility. Type 2 TVSS devices are installed at branch panels, protecting downstream equipment. Type 3 TVSS devices are point-of-use devices, such as surge strips, protecting individual electronic devices. Lightning protection systems work by providing a safe path for lightning current to flow to ground, minimizing damage to structures and equipment. These systems typically consist of hair terminals, or lightning rods, conductors, and grounding electrodes. Air terminals are installed on the highest points of a building to intercept lightning strikes. Conductors are used to carry the lightning current from the air terminals to the grounding electrodes. Grounding electrodes are buried in the earth to dissipate the lightning current safely. Regular maintenance is essential for ensuring the effectiveness of TVSS and lightning protection systems. Inspect TVSS devices periodically for signs of damage, such as blown fuses or tripped circuit breakers. Test the grounding system of lightning protection systems to ensure it is still effective. Keep records of all inspections and maintenance activities. When dealing with electrical systems, safety should always be the top priority. Firstly, always energize circuits before working on them. Secondly, use appropriate personal protective equipment, such as gloves and safety glasses. Thirdly, follow all applicable electrical codes and standards. Fourthly, if you are not comfortable working with electrical systems, hire a qualified electrician. Understanding the terminology associated with TVSS is crucial for making informed decisions. Surge current is the momentary burst of current caused by a voltage spike. Voltage protection rating, or volts per mode, is the maximum voltage that a TVSS will allow to pass through to the protected equipment. Clamping voltage is the voltage level at which the TVSS begins to divert surge current. Response time is the time it takes for the TVSS to react to a voltage spike. Maximum continuous operating voltage, or MACOV, is the highest voltage that the TVSS can continuously withstand without degrading. Energy absorption capacity is the amount of energy, measured in joules, that the TVSS can absorb before failing. When evaluating different TVSS options, consider several factors. Firstly, the type of equipment you need to protect. Secondly, the frequency and severity of voltage surges in your area. Thirdly, the environmental conditions in which the TVSS will be installed. Fourthly, your budget. TVSS technology continues to evolve, with new features and capabilities being developed. Some modern TVSS devices include advanced monitoring and diagnostic features, allowing you to track their performance and identify potential problems. Others incorporate filtering technology to reduce noise and improve power quality. Staying up to date on the latest TVSS technology can help you make informed decisions and ensure you are using the best possible protection for your equipment. In summary, protecting your facility from lightning strikes and voltage surges requires a comprehensive approach that includes selecting the right TVSS devices, installing them correctly, and maintaining them regularly. By following these guidelines, you can minimize the risk of damage to your equipment and ensure the safety of your staff.